Right, we're going to start today in Module 6, Homework 1, and this gives us our first use of the factoring, really. So factoring, solving equations by factoring. So we're looking at Mod 6, Homework 1. We're going to solve. So what kind of symbol do solve problems have? And equals. So all of these are going to have an equals in there. What I see sometimes is that students, once they learn this, because this is later than the factoring, then they will try to solve every single one. Don't solve unless it has an equals. Right? And what we're going to look at is a new kind of equation for us. We've solved linear equations before, and that means the exponents are 1. What we're going to work on now are quadratic equations, or equations that we can factor. And so we're going to have more solutions. And then we will learn other techniques where we could solve quadratic equations, but we might have some bigger in this section. Right. So I'm just going to sidetrack for a second before we start the problems and just say the rule. So to solve by factoring, we use what's called the zero product law, and it says if you can get a product on one side and 0 on the other, then one of these pieces has to be 0. So that is what we're using. The important pieces in this theorem is that one side has to be 0. That's the only way it'll work. The other side has to be a product, and that's where your factoring comes in. Once you have that, then you break it apart and you set each one equal to 0. So we'll go ahead. The first one is already factored for you. Right? If it was multiplied, we don't need to multiply, but if it was, it would be h squared, which means we should get 2 solutions this time. But it is in the form a times b equals 0. So we set each piece equal to 0 and solve. So here we add 13, so h equals 13. Here we would subtract 5, which equals -5. Normally now we will put the answers in solution set symbols, not parentheses. Make sure they're the braces. And you probably don't have to enter that at all, but that is how you should write it. And it's just because there's more than one answer, we kind of group them together. So 13 and -5. We'll do question 2 on here also. I am just going to erase this line a little bit, make it shorter, and we'll do question 2. So this says, oh, this one is longer. I need a whole page. I thought that was a 0. Sorry. So this one took you to a hard one, kind of, there's a jump in there. I should have glanced at this order first. This one does not have the 0. It has the product, but it does not have the 0. So you have to have a 0. So we need to move that 22 to the other side, which means we'll add it to make it move. And that will give us a 0 over here. But now it's messed up our factoring. So we're actually going to have to multiply it out. And then factor it. So we have a trinomial, 2 sets of parentheses, do your signs. This says do like signs both plus. Split your p's. and we're multiplying to get 22. So we can do 1 times 22 or 2 times 11. They're going to add to give 13, so 2 and 11. And they're both plus, so it doesn't matter where we put them. Now we have the proper form. Make sure you check 11p plus 2p, 13p, because if you factor wrong, the next step's going to be wrong. All right, and now you just break it apart and set each one equal to 0. So this one is p equals negative 2, and this one is p equals negative 11. And we'll just group them back, negative 11 and negative 2. Good. All right. This is the kind I was thinking that was. Which this one is already set up. You have your A, you have your B, and you have your 0. So it's ready to break apart. Set the first one equal to 0, and then we'll set the second one equal to 0. So the first one is actually already solved. So 0 is fine. 0 is an answer. That's one of the numbers. And this one we will subtract 12. So negative 12 and 0 are our answers. If it was multiplied, it would be x squared. So we should get 2 answers. Most of the time you get 2 answers. There's one case where you don't. All right. All right. This is a weird looking question. It wants us to solve x squared plus 15x plus 56 equals 0. Right? It is a quadratic equation. That's what you want to notice. First of all, notice your equals. It's an equation. Okay, so it is solved. Second, you want to notice it has a 2, so it's the new kind. If it just had x to the first, then we would isolate the variable. All right, but it is the new kind. So you want to go with this rule, and it says, okay, get a 0 on one side we have. You need a product on the other side. So we have to factor, and this says do like signs, both plus, split the x's, and for 56. You can make the list. 7 and 8 kind of pop in my head. If it pops in your head, go with it. If it doesn't, you make the list. 1 times 56, 2 times, whatever. But if you get the right one, just use it. And so then you set each one equal to 0. So x plus 7 equals 0. X plus 8 equals 0. And we'll solve. So we'll subtract 7. And this one we will subtract 8. So negative 8 and negative 7. All right, let's see how they're asking us. Box 1, they want the larger solution. The larger solution is actually the negative 7. And the smaller solution is negative 8. So I don't know why they changed up the format there. All right, and here they're going to give us a multiple choice question. Right, we do have a quadratic equation. Okay, and we have a 0 on one side. On this side, we have to factor, and this is one of those that is not so nice because it has the number in the front. So it's a trinomial. We can't get rid of the 7. We're stuck with it. When I showed you guys this, I did 2 methods. I did trial and error, or I did factor it by grouping. Anybody have a preference? All right, I'm going to do it by trial and error then, because 7 is a prime number. So hopefully that will help me. right? So it would be 7 and 1 would be my choice. Here I'm going to use different signs, and then I have to look at the factors of 12. So 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. Ooh, kind of nasty. All right, so we want to pick something, and we just have to try them, and we have no shortcut to help us because there's no common factor with 7. So I would probably go to these numbers closer together and try them first. And since I only have 7 and 1, I can kind of mark them off here. So I am going to try 3 and 4. So minus 28x plus 3x, and that is minus 25, and that is not it. All right, so that one's out. Now you wouldn't cross them out if you had more things over here to try. All right, so I'm going to switch and try 4 and 3. All right, so there is a minus 21x plus 4x, and that gives us a negative 17x. Almost works. Remember, once you get the right number, all you have to do is switch the signs. So my plus should have been minus, and my minus should have been plus. So it should factor 7x minus 4, x plus 3, and over here we have our 0. So there's your 21 minus 4, 17. Now you break it apart, and you set this piece equal to 0, or this piece equal to 0. All right, we'll do this one first. It's easier. Negative 3, this one's a 2-step. Add your 4. I'm going to just do it. If you need to write the step, please still do it. And then you'll divide by 4. So our answers are negative 3 and 4/7. All right, and so actually it is the first one. And if you were real stuck on your factoring, you can look at these answers and kind of play with it. You're going to need the 4 and 3 to get any of these. All right. Good. All right. 6 is a nice question because the factoring is going to be easier. So we have x squared minus 14x plus 24 equals 0. Right, so it is an equation. It is a quadratic equation because of the 2. So we looked here, then we looked here to tell us what to do. We have the 0, so we're going to try to factor. And this is a trinomial, so 2 sets of parentheses. It says do like signs both minus. We're going to split the x's, and we're multiplying to get 24. So 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And when the coefficient of the x squared is 1, you can look through the list. You don't need both orders. And we're going to add with like signs to get 14. It is going to be 12 and 2. And your order doesn't matter. If you put the 12 here and the 2 here there, it doesn't matter. Right? Double check. I'm not going to write the check, but I'm just going to check. So in my head. So minus 12x minus 2x is minus 14x. It would be in the way. That's why I did not. But you need to check. All right. So we set each one equal to 0. And solve. So this one will add 2. This one will add 12. And we're good. 2 and 12. You guys stop me if you have a question as we go. I'm not sure what happened there. If you logged in as Zoom user, can you please tell me who you are in the chat? All right, so if you can't tell me in the chat who you are for a Zoom user or speak, then I'm going to take you out of our session. Okay, thank you very much. I'm not sure how this happened, and I didn't want anybody in there who wasn't really a student. Okay, thank you very much. All right, so here we have another quadratic equation with a 0. So we have the 0 we need to factor. This one is a difference of squares, and so we have 7x plus 5, so use your square roots, and 7x minus 5. It is 2 terms. For 2 terms, your choice is squares or cubes if there was no GCF. So now you're set, and for this one, we'll just set equal to 0, and this one just set equal to 0. So we're going to subtract 5 and divide by 7. So x equals negative 5/7, and this one we add 5 and divide by 7. So x equals 5/7 and negative 5/7. Good. So hopefully you're thinking about the kinds of factoring here. No idea how that happened. Okay. So this one I am hoping is one of those perfect square trinomials. All right, and before we even get to that thought, it does have the equals. Yes. It does have an exponent of 2. Yes. Right? So we have the 0, and we try to factor. We have a perfect square at the front and a perfect square at the end. So guess the square roots. And so it'll be 9x, 9x. This says like signs both plus. And 64, the square root is 8. And we just have to check. So this is on the outside 72x, inside plus 72x equals 144x, and we're good there. We needed that to be able to say this was the correct factoring. So this one is a perfect square trinomial. Notice how just seeing this perfect square and this perfect square kind of jumps out at you rather than going to the trial and error. Now, this is one that is going to actually only give you one solution because they're just alike. And that is the case where you won't get as many as the exponent. All right, so you're going to subtract your 8 and divide by 9. So x equals negative 8/9. This one gives you the same thing, so there's no reason to have to do it, and you just put the answer one time. So that is your instance where you would get only one answer. All right, number 9. All right, so we have an equation. You see the equals, exponent of 2. So it is this kind. We do have a 0. On the other side, we are going to factor. So don't forget about GCF. You can take out a p here. So p minus 6. And then set each one equal to 0. So this one is 0, or this one is 0. This one is solved. add your 6 for this one. So 0 and 6. So number 10, we have p squared equals 19p minus 90, right? It is an equation, it has the equals. We have an exponent of 2, so it is this new kind. You need to get everything on one side 0, on the other side. You want to keep a positive square term, so move them to the left, even though you have to move 2 things. So I'm going to keep the p squared. I'm going to subtract 19p, and I have to add 90. That will give me 0. Then I'll try to factor, and so it is a trinomial. It is the nice one. It has a 1 in the front. Right, do your signs. At the end it's plus. That says like signs, whatever this middle term is. Split your p's. And you're looking at 90. So things that multiply to give 90. 9 and 10 might pop in your head. If not, you make the list. So it would be 1 times 90, 2 times 45, 3 times 30, 4, I don't think 4 goes. 5 will go, I don't remember how many times. All right, but 9 times 10 is the one that's going to work. So you can keep checking the list, but that one popped in my head. And I did not need both orders. They do add to give 19. So 9 and 10. And then you set each one equal to 0 and solve. So you're going to add your 9 and you're going to add your 10. So 2 answers. Right. 11 looks to me like another perfect square trinomial. You just have to verify that for the factoring. It is an equation, has the equals. It has an exponent of 2, so you know it's this kind. You have a 0. So we have a perfect square here and a perfect square here. So most likely that works. Remember to use your square roots. So this would be a 9x, and for 4 would be a 2. Our signs, like signs, both plus. Right. So this one is similar to the one we had a little bit ago. You only have to solve one of them. It's going to give you the same solution. So we'll subtract the 2 and divide by 9. So negative 2/9 is our answer. Right, so this one, p squared minus 1 equals 0. This one is a difference of squares. So this is going to be p plus 1 and p minus 1. It was 2 terms and an exponent of 2. You have to look at the exponent to see if it is a cube or a square. And then you set each one equal to 0. So this is p equals negative 1. And this is p equals 1. So 2 answers. Here we go. I think I'm going to skip that one. It's a multiple choice. It's going to be the hard factoring. 7, it can be the trial and error or the grouping. So I'm going to skip it. we have another section today, so that's why I might skip some. Let's see. This one I'm going to do. Oh, I thought there was a common factor all the way through. So it really is like the other one I just threw out, or didn't. I skipped it. Okay. This one is really the same kind as that. It's going to be a trial and error. I thought when I glanced at it that this had a common factor, but it does not with the 19. So I wrote it down so we can do it. Let's see. So nothing to take out. So we have 15 and 1 or 5 and 3 that we'll use over here. And we have 1 and 6, 2 and 3, 3 and 2, or 6 and 1. Like signs both plus. And I'm going to try the 5 and 3. And then I'm going to pick numbers closer together. Actually, I have a little shortcut. I can throw away, with the 5 and 3, I can leave out the 2 and 3. And I can leave out the 1 and 6, because those would put common factors in the second set of parentheses. So I'm going to try 3 and 2. And there is 10W plus 9W, and that one is working. So I ruled 2 out and found 1. All right, so I have, this is equal to 0. So 5W plus 3 equals 0, or 3W plus 2 equals 0. Subtract your 3, so 5W equals negative 3. And divide by 5. So W equals negative 3/5. Next one, subtract your 2. So 3W equals negative 2, and divide by 3. So W equals negative 2/3. So negative 2/3 and negative 3/5. And there we go. And I didn't put them in our nice little symbol. This one I wanted to do for you because it has a GCF. And you have one clue that it does. If you glance at it, you notice that your degree, or your highest exponent, is 3. Right? And you're a little concerned by that. So when we look at it, we do have a y in each one. So we can take a y out. That will leave 15y squared plus 4y minus 4 equals 0. And this y, I'm just going to need to bring it down with my solving. All right, for my factoring here, this is one of those trinomials that's not nice. It has the number in the front. I did the others by trial and error. Let's do this one by grouping, just so you have a sample for those who like that. So we're just dealing with the factoring right now. You keep the first and you keep the last, and you're going to split the middle. So 15y squared and a minus 4 over here. To find your numbers, you have to multiply first times last. So 15 times 4 will be 60. So we're looking through 60. So we have 1 times 60, 2 times 30. I'm just dividing on my calculator into 60. 3 times 20, 4 times 15, 5 times 12, and 6 times 10. After that, I think it turns over. We don't need both orders here when we're using this method, because it doesn't matter where you put them. So we want different signs, because it ends in negative, and that means that they're going to subtract. So they're going to subtract to give me a 4. 10 and 6. will be the choice. And I want it to give me a positive 4. So I need the plus with the 4 and the minus with the 6. Right? And I am going to put the 10y here because it has a common factor with 15. You put a y with each one. And just make sure those combine to give the one above. All right, now we'll go through the factoring. So here we can take out a 5y. And that leaves 3y plus 2. This one will take out a minus 2. And that leaves us a 3y plus 2 because we took the minus to the outside. We did get the common binomial, 3y plus 2, and we'll pick up the missing pieces, 5y minus 2. All right, now, when you get that factored, don't forget this y up here because you're going to need it with your answers. You're going to get 3 answers on this one, and you get 3 answers because your exponent, your degree, your highest exponent was a 3. So now you set each one equal to 0. Well, the first one is already done for you. Y equals 0. The second one, 3y plus 2 equals 0. You're going to subtract your 2. So 3y equals negative 2 and divide by 3. Right? And your third one, 5y minus 2 equals 0. So you're going to add your 2. So 5y equals 2 and divide by 5. All right, so we have a negative 2/3. We have 0, and we have 2/5. Excuse me. Sorry. All right, very good. Next one I'm going to skip. We've done several like this at this point. It is a quadratic equation. It has an equals as an exponent of 2. You have the 0 you need to factor on the left-hand side. And there's your answer. Nothing different on this one. Also a quadratic equation. Your factoring is a little bit harder. There's your answer. This one is a difference of squares. We did one. We'll do one more. I don't remember doing a bunch of those. So x squared minus 9 equals 0. And so we'll factor on this side. X plus 3, x minus 3 equals 0. And then you set each one equal to 0. So here we'll get negative 3, and here we'll get, add your 3, we'll get plus 3. All right, let's see what kind of stuff we have here at the end. 19. The width of a rectangle is 2 meters longer, 2 meters less than the length, okay? The area of the rectangle is 80 square meters. Find the length and the width of the rectangle. All right. So I need a picture. That is just for me. Okay. The width is 2 meters less than the length. Normally when you set these up, pick the one for your variable that they say nothing about. We only want to use one kind of variable. So the width is 2 meters less than the length. They say nothing else about the length, so I'm going to call the length L. And the width I'm going to translate in terms of L, right? Less than is subtract, and it goes backwards. So the 2 is going after your minus sign. All right, so I have L and L minus 2 and L minus 2, right? It says the area of the rectangle is 80 square meters. Area is length times width. So you would need to know that from somewhere in your life. Area of a rectangle is length times width. And that, I shouldn't write L there because I've used L for one of my, it is length times width. That's the formula. All right, and then we can just plug in because we have our pieces. Well, our length is L, and our width is L minus 2. And so we have L squared minus 2L. Right? That's the expression for our area. Now, they have told us that the area is 80. So area equals 80. That was given in the problem. And I'm not worried about the unit. So we figured out an expression for the area. So L squared minus 2L equals 80. And we can solve this. We need to get the 80 on the other side. Hopefully I can get a little more space here. All right, my screen is really messed up. So we're going to subtract the 80. I'm going to go over here. L squared minus 2L minus 80 equals 0. And now you're going to factor. So we have L and L, different signs. And for 80, and we're going to subtract to get a 2, so these shouldn't be so far apart. 1 times 80, 2 times 40, 3 doesn't work. 4 will go in there, 4 times 20. 5 should go in there, so we just pull a calculator. 80 divided by 5. 16 and 5. We're getting closer. It's going to be 8 and 10. That should have popped in my head, but it didn't. All right. You could try 6 is not going to work because we have no 3. 7 you could try, and then we would get to 8 and 10. All right. So 8 and 10 is going to work. You want a minus 2L, so your 10 needs to go there, and your 8 needs to go here. Check. Minus 10 plus 8, that works. And so this gives us L plus 8 equals 0. So L equals negative 8. And this one gives us L minus 10 equals 0. So L equals 10. You don't want the negative value because you're doing a real world problem. And so you're going to throw that one out. You're going to keep the 10. So your length is 10. And your width is going to be 10 minus 2 equals 8 if we have to answer both of those. Yes, we do. All right, so let's get this calculator out of the way. So my length is 10. And I'll just look. And the width is 8. Okay, so I threw this one out. I threw the negative out because you're not going to have a negative length. I used the 10, but I had to substitute back to get the other one. All right, this one is going to be the same kind of setup. We'll go ahead and do it. So it might seem difficult to you. At least you'll have it set up. All right, so we're working with a rectangular again and the area. We know a rectangle has length and width. And it says the length of the rectangle is 2 times as long as the width. So the width we don't know. The length is 2 times as long. That would be a multiplication. All right. And now you'll use the formula for area. Area equals length times width. That is for a rectangle. And so we have 2W times W. And that is 2W squared. And they gave us it equals 162. So 162 equals 2w squared. With the factoring that we know or with the solving that we know right now, you would move the 62 to this side so you get a 0. And then we'll factor. I will take the 2 out. And 2 into 162 will go 81. This will factor to difference of squares. Right, and then you set each one equal to 0 and solve. You are not going to get an answer from the 2 because it has no variable. And that might occur some in those other problems also. If there's no variable, you're not going to get a solution. You just ignore that part. It's like you can divide the 2 out and you have the same thing. Right? So this piece, when we set it equal to 0, we get -9, and we're going to ignore that one. This one we're going to get +9. All right, so my width is 9. My length is 2 times 9. Should be 18. So 18 and 9. All right. Hang with me for just a minute and let me switch sections. That kind of caught me by surprise today when I saw I had put 2 on there. Okay. So the square root method. This is the second method of solving quadratic equations. Now, it is only for quadratic equations. This factor and use the zero product law that we had earlier. For this section, you can actually use for any kind of equation if you can factor it. So it could be a higher degree, like that one that we had was x to the third. All right, so we're going to switch gears and look at Mod 6, Homework 3. And this is solving quadratic equations by the square root method. All right, and I'm going to go ahead and just mention the rule here, right? And basically it is, if you have this form, x squared equals some constant, any constant, right? You can take the square root of both sides, right? And when you take the square root here, it will just be x, but on this side, you're going to get plus and minus, the square root of whatever this is. So to do this rule, you need to get x by itself, or in some cases, a binomial by itself. All right. So our first one is a nice one. It's the exact setup of the rule. You have t squared equals 25, and so we'll take the square root of both sides. It's set up. It is an equation, has an exponent of 2, but it's something squared equals some constant. Do your square root of both sides. For this one, I'm going to write the steps. Right, I'm doing the square root on both sides, but on this side I have to do plus and minus. And the square root cancels out the exponent. So t equals plus or minus, and square root of 25 is 5. So you did get 2 answers. There is no plus or minus button in the software, so you'll have to write them both. Okay, I am going to come back to 2. So, remind me if I forget. All right. Let's see if there's another nice one before we get that bad. Yeah, we're going to skip a minute. We're going to go to number 6. M squared equals 40. All right. This one is the right setup. you have m squared equals some constant. So take your square root of both sides. It's going to give you m equals plus or minus the square root of 40. Now, if this is not a perfect square, you have to simplify it. So 40, you could do 4 times 10, and there's 2 times 2 and 2 times 5. So your 4 gives you a square. 1, 2 is going to go outside. It needs to go right next to the radical. So you're going to have 2 times the square root of 10. And that is our answer on this one. Let's type it in just so you won't have any trouble. So I need to do the 2 and the plain radical and a 10. Make sure you're out from under that radical. You can click at the end or use the arrow on your keyboard. And now we'll do the other one, but your 2 is right beside the radical. And I need to put minus there. And they don't care about the order. All right. Okay. Let's look next. So I'm going to jump around. This one is good. Root 4. So I have c plus 1 squared equals 19. This one, if you just pretend like this c plus 1 is x, all right, you have x squared equals some constant. This is the best way to solve this one. You don't want to write this twice and do FOIL and go through all of a different method. That's way too much work. This is a nice short one. Take the square root of both sides. C plus 1, think of it as x. All right, so you're doing the whole thing. That's an x. Take the square root of both sides, and I'll write the step since it looks a little different. Over here we get plus and minus. C plus 1 squared, and 19 here. The radical and the exponent cancel each other. So you have c plus 1 equals plus or minus square root of 19. 19 is a prime, so the radical's not going to simplify. You have one more step to do. You want just c, so you need to get rid of this 1. You're going to subtract a 1, and it's very important, put it in front of the plus and minus. That way it will pick up both of those. And sometimes the answer will show it at the end, but I would just put it at the front. If you put it at the front every time, that is what's standard, and you'll get it right. You won't mess up the signs if you do that. All right, let me see what exactly they're asking me. Where a equals, well, a here is -1. All right, and b equals square root of 19. So just the way they worded it, they didn't really ask me for both of those, but that was it. All right, I'm going to go to 5 next. And this one, it's almost the way you want. Something squared equals a constant. What you don't like over here is this 8. Right? It's multiplied, so you can divide it out. That's fine to do, as long as you do it to both sides. And then it gives you the form you want. And that gives us a 9. And then you continue. Now you have something squared equals a constant. Take your square root of both sides. On this side it will give you n. Over here you get plus and minus square root of 9, which is a perfect square. So this one gives us plus or minus 3. So negative 3 and plus 3. All right. Let's see what else was in that list. All right, so there's a couple of those. All right, let's do one more of these binomial ones, and then I'll do one where you have to get one of those pieces by itself. All right, number 9, you have r minus 2 squared equals 17. It is set to take your square root of both sides. The r minus 2 is like an x, right? So if we take the square root of both sides, it will get this one off. I'll write the step because sometimes this bothers people. This and this go away. So you have r minus 2 plus and minus square root of 17. And all you have left to do is get the 2 off. So you're going to add a 2 and just do it at the front. So you have r equals 2 plus or minus square root of 17. So we'll type those in. So I will do 2 plus square root of 17. I have to remember to get back out from under the radical and put my comma. And then I have 2 minus square root of 17. And we'll submit on that one. Let's do 12. All right, and this one you might worry if it is the kind 2 factor, if they're just all mixed up. Your clue that you can use the square root method is because there's no m to the first. It's m squared and everything else is plain numbers. So let's isolate the m squared. So we're going to add a 21 to both sides. That gives us 2m squared equals 32. Divide out this 2 because we just want m squared. We don't want anything else over there. So we have m squared equals 16. Now use your square root method. So m equals plus or minus square root of 16, which is a perfect square, plus or minus 4. There we go. And I'm going to skip that one. I haven't looked at it. Oh, there's the Pythagorean theorem ones. Let me save those for just a minute. Let's go back and do that first one I skipped, problem number 2. This one. And what you have to remember is to just get that square piece isolated. Right, so this is one of those, if we just get the parentheses could be like a y squared, right? It doesn't have a plain y term there. So take off your 3, so you need to isolate that first. So add a 3, and we get 3 times the x plus 5 squared equals 147. Divide out the 3. So you get x plus 5 squared equals, and this is probably going to divide. Equals 49. Then you can do your square root method. So if you do it on the left, it will leave you x plus 5. When you do it on the right, you get plus and minus square root of 49 is 7. square root of 7. Right, and now you're going to move your 5. So you are going to subtract 5. Whoops. Has to go in front of the plus and minus. So x equals negative 5 plus or minus square root of, you know what? This is h messed up there. Did you guys catch that? 49 is a perfect square. You no longer have the square root. This is good. Not that I messed up, but it's that we have this kind of problem. This one's going to take you one more step, right? When you get plain numbers here, you have to combine them and simplify this. So we're going to do negative 5 plus 7. So I'm going with the plus first. So negative 5 plus 7 gives me 2. And a negative 5 minus 7 gives me a negative 12. So these are my answers, 2 and negative 12 on this one. Good. All right. Let's go down and we'll do the Pythagorean theorem ones. So a couple of application. So mainly remember, isolate your square term or isolate your parentheses there before you do them. All right. And I think you would use this same theorem that's on 14 for the one above. All right, so it says, in the following figure, find the length of the unknown side of the triangle. Give an exact answer, and then an answer correct to 5 decimal places. All right, so what we have is a right triangle, and we have a theorem. Pythagorean's theorem. This is only for right triangles. A right triangle has 190-degree angle, and they'll put a little box in that, right? And on this triangle, the side opposite is called the hypotenuse. The other two sides are called legs, and they don't differentiate them, right? Our theorem is, we're going to label this triangle. The hypotenuse is always C. These other two are A and B. A and B. Right, and the theorem says A squared plus B squared equals C squared. And this theorem lets you find the length of one side. So if you know two sides, you can find the length of the other side with this theorem. And so for our triangle, I'm just going to flip it over. So I'm going to flip it this way. This one is 11, and this one is 8, and it is the hypotenuse that we don't know. So it's the C that we don't know. I'm going to relabel it. Okay? And so I would write the formula, A squared plus B squared equals C squared. Right? These are A and B. So I have 8 squared plus 11 squared equals C squared. 8 squared is 64. 11 squared is 121. You can test that on your calculator. And let's add these together. So that is a 5 and 8, and 185 equals C squared. We don't want C squared, we want C. So we're going to take the square root, and normally here we would do the, you would get plus and minus, right? So we would do the square root method normally. So C equals plus or minus the square root of 185, right? And that is not a perfect square. If you try to see, can you do a square root? All right, and so our square root button, so second square root, 185. Right, so I'm going to leave that up there because it asks us for 2 ways to put the answer in. Let's see if I can get a little more space. Okay, the exact answer is going to be to simplify that radical. Right, so if we take 185 and we break that down. You know what? This says to do it to 5 decimal places. I'm going to need my calculator. That is why I am saying I'm going to go ahead and write it down. So it said to enter it to 5 decimal places, I believe. Give an exact answer and an answer correct to 5 decimal places. All right, so I'm going to write this down. And before we get there, you're not going to get a negative length. All right, so you're going to throw out the negative and just use the positive because it's length. Right, and a decimal approximation, I'm going to use a wavy line for a decimal approximation, 13.60147. That's 5 places. The next one is a 0. I had to see the next one. If it was 5 or higher, it would push this one up. So this would be the answer to 5 decimal places. All right, now let's break it down. And this is a skill you've done before to simplify the radical. So I know there is a 5 in 185. So 185 divided by 5. So 5 times 37. And that is very nice because 37 is prime and 5 is prime. And so it's not going to simplify. So the exact answer is square root of 85. Square root of 185. Hopefully I didn't make an error there. All right, and the exact answer, the rounded answer, I'm saying all my words wrong. Time to end, huh? Close. All right, good. So there you have an example of one of those. For this one, I would not bother to memorize 2 formulas. I would use 1 formula and do some algebra skills, so I wouldn't do everything that's in that formula. They want us to find the length of A, which is a side that is not the hypotenuse. I would just use A squared plus B squared equals C squared. Always works for a right triangle. Put our right triangle here. And A is what we're looking for. We know 16, we know 20. So this will be B, and this one is C. The C is the one you have to get right. All right, so we have A squared. We don't know A. B we know is 16, and we'll square it. And C we know is 20, and we'll square it. So work those out on your calculator. So 16 to the second, 256, and 20 squared, I believe, is 400. Isolate your A squared. And now you have the square root method to do. So A equals plus or minus square root of 144. 144 is a perfect square. Since it is a real-world question where you are finding a length, you're going to throw out the negative. So A equals 12 is the answer you're going to use. Good. All right. Let's backtrack and look at 13 so it won't bother you and at least get it set up. All right, so laptop computers are measured according to the diagonals of their screen. a 16-inch laptop has a screen that is 8 inches tall. How wide is the screen? So what you have, if you just use half of it, is a right triangle. And that's what you want to see, right? You know that this hypotenuse is 16, and this side is 8, and this one we can just call A. So our theorem is a squared plus b squared equals c squared. So you have to know that theorem. The a we don't know. The b is 8 and 16 squared. This gives us 64 and 16 squared. I already had that one on there. 256. And that really is a very bad habit, what I just showed you, leaving all that stuff on your calculator. It's better to clear it. I'm going to subtract that 64. And then when my a squared is isolated, I can take the square root. So a is going to be plus or minus square root of 192. Real world problem, we won't want the negative. So a equals square root of 192. 192, does it break down? Okay, we can try. So let's see how does it say for the answer? All right, it wants an approximate answer, so we don't have to break it down. Okay, so we can plug 192, we have to plug it into our calculator. Square root, so second square root, 192, close your parentheses, enter. All right, and so we have 13.856406. 856406. Let's see how many places they said. To 2 decimal places. So I didn't need all that. I just needed to see to this 6. This 6, you wanted 2. You look one to the right. This 6 is going to push you up. So it's going to be 13.86. And they gave the whole thing to it. Let's answer it. And there you go. All right, I think that is enough for today. We did a lot of work. So I will see you guys next time, and have a great day. Work hard on this stuff. Bye.